Define the current sensitivity of galvanometer. Define the current sensitivity of galvanometer. Okay. Write its expression. Right. Second question. A galvanometer has resistance E and shows a full-scale deflection at current Ig. How can it be converted into ammeter to measure the current up to I naught? That is, I naught is greater than Ig. What is effective resistance of this ammeter? Now, எப்போதுமே ஒரு கொஸ்டின் கொடுத்தா you must try to enter the given detail perfectly and then try to just repeat the questions asked here. Okay. Now, define current sensitivity. Take down current sensitivity. This is the first one they have taken asked. Second, of a current sensitivity of galvanometer. Then write its expression. So we must give the expression. And then second question. A galvanometer has a resistance G. So galvanometer resistance is equal to G. Shows full scale deflection. So it is showing full scale deflection. That is, it goes to the extreme position. Deflection. For current Ig. For current Ig. Ig means what? That is the maximum current it can go. Okay. Then
I is the maximum. I naught is the peak.
Ig, the current carried by this galvanometer to the maximum extent. Then, now the question is, how can we convert? How can it be converted into an ammeter? So our idea is a galvanometer should be converted into ammeter. Okay. Ammeter to measure the current. To measure current. Right now. To measure current. And what is the condition? Up to I naught. In this case, I naught is greater than Ig. And this is A. B is, what is the effective resistance of this ammeter? So the effective resistance of the so-called conversion of ammeter, galvanometer to ammeter we are converted. So for which they have asked the effective resistance. Okay, right. Now let us proceed one by one. The first one. What is current resistivity? Current resistivity is nothing but the deflection produced in the galvanometer.
Sensitivity.
Sorry, resistivity. Current sensitivity. Current sensitivity is the deflection. Take down. Is the deflection. Deflection produced by the galvanometer. Produced by the galvanometer. When I say galvanometer, moving coil galvanometer. Galvanometer. When unit current flows. When unit current flows through it. And the expression is I is equal to K. What is K? Torque. Then N number of turns of coil. N number of turns of coil. And then A. Area enveloped by the coil. B. The magnetic field. And the phi value. What is phi? Okay, right. So the current sensitivity of a galvanometer is defined as the angle of deflection. That is this one. Angle of deflection per unit current flowing through it. That is angle of deflection per unit current. This is unit current. Unit current means per ampere. Okay, so simply it can be represented as a pi for 1 ampere. Am I right?
5 by I.
That is pi by I. Pi by I. So this is called current sensitivity. Okay, that is pi by I, where I is equal to unit. Unit means 1 ampere. Okay, so this part is over. Okay, now let us move to this. The galvanometer is converted into ammeter. How can you convert this? We have to use this. For instance, that is you have got the current here. Okay, take down I, and you have got the galvanometer G. Okay, now this is the current, and from here you have to connect a shunt resistance. What is shunt resistance? A small resistor connector parallel to the galvanometer. So the current flows like this. You have to be very careful about the direction of current. Okay. Now, after the shunt, when it goes here, this is Ig, right? That is current passing through the galvanometer. And what about this I and this is G? Listen carefully. This is I, this is G, right? Okay. Now, what about this current? Can you tell me?
Current near the galvanometer.
This one.
I minus I.
Very good. I minus Ig. And then here the shunt resistance, yes.
Yes.
Okay. That's it. Now, the galvanometer can be converted into ammeter by connecting a small resistor that is called shunt parallel to the galvanometer. So this we have to note down. So this is the second answer. Take down. Galvanometer can be converted into ammeter. How?
By using
By connecting shunt resistance. Yes, is shunt, the small resistance parallel to the galvanometer. In a short way, you can write down, but not in the examination. This is for note taking purpose, okay? For your personal studies, right? Now, as the galvanometer is connected to the shunt, okay? Now, the potential across the G, the potential across G
is equal to
is equal to the volt will remains the same. When it is parallel, the potential across G is equal to, because V is constant here, okay, and the shunt potential. Okay, so you can call it potential
cross shunt.
across
Shunt.
shunt, right? So in that case, this is nothing but V. This is also V. This is of G. This is of S.
Yes.
And you can apply once again Ohm's law, right? So what is Ohm's law? Apply Ohm's law.
IRG.
Vg is equal V is equal to IR. Is it not? So for this, in terms of current, Ig. Why Ig? Because Ig is the current passing through the galvanometer, and Ig, and you have another one into R. So what is R here? That is the galvanometer resistance. You can simply put G. You can call it RG or G, both the same. Okay. So maintain G is nothing but RG only. Okay. Right. So I am simply representing Ig into G. Right. That is equal to. And what about this Vs? That is Is. So what is this Is? Is is nothing but yes. So Is is equal to I minus Ig, right? Because that is the current passing through the shunt, right? So you can introduce Here
I'm not
that is I minus, better you can put like this, Ig into G is equal to Is into S.
Yes.
Okay. Now in the next step you can bring. So this Is is nothing but I minus Ig, right? So you can replace this I minus Ig into,
Yes.
what is that? Yes. Now our idea is to find out the shunt. Okay. So the shunt is equal to Ig into G divided by I minus Ig. Right. So this is the,
Not
okay. So this is the shunt resistors. Right. So to measure the current up to this one full scale. Okay. So that is why it is a deflecting full scale for G means that is a IG. Okay. Right. Now, um, that is, let us move to the next one. B. What is asked in B?
effective.
Effective
It's of the ammeter.
resistance. Okay, take a effective resistance. So the effective resistance of the ammeter, the so-called ammeter. In fact, that is with the help of this one, we can find out the I. Do you understand? Okay. What is the purpose? What they ask? They asked how to measure the current. Okay. It means what? Using Ig, Ig value you know, G value you know, and the S value, that is the resistance we are given. From this you can find out I value. You can measure the current. Got this point? So this is the way, using this, you can mention this. Using all these parameters. Which are the parameters known? You can mention like this. That is S is known, G is known, Ig is known. From this I can be calculated. That's it. Okay. So I hope when you are capable of measuring I, automatically that galvanometer becomes ammeter. Do you understand this meaning? Okay. Right. Next, let us move to the effective resistance. What is effective resistance? So 1 by or S is equal to, we are talking about the ammeter. Okay, the net resistance we are talking. So 1 by RS. Why RS? What is RS? Shunt. Right. RS means what?
Shunt.
Shunt resistance. Okay. So why I have put 1 by RS? Do you know? Because it is connected here. We had applied that concept. 1 by R is equal to, if it is a parallel circuit, 1 by R, 1 plus
One by
the same logic only. Okay. So here 1 by RS is equal to, now look at the diagram. We have got two resistors. One is galvanometer itself is a resistor. Shunt is another small resistor, right? You can call any wire as a resistor. Without resistance, you cannot have any conductor at all. You cannot claim any zero resistance. Then it becomes a superconductor. You are not using any superconductor. So if it is a conductor, if it is a wire, there must be some resistance. Okay. For example, if you are a student, there must be some foolishness. Without foolishness means you are not a student, you become a guru. I hope now you should be able to understand. Conductance is like that. So this 1 by R. So these two are the resistors. Okay, what are those resistors? What about this is G and this one? Yes, that's all. If you want, you can put R as DS or G R as also. But you can maintain as G and S. So 1 by R1 instead of that 1 by G plus 1 by S. That's it. Now we want to know the effective resistance, is it not? So take the LCM, GS, this one, G plus S plus G, or both of them is equal to 1 by, now effective resistance means the RS only, not the reciprocal. So we are interested in the reciprocal. So I mean RS only. So yes, Jesus. So you have to put the answer finally like this. Don't stop with this. Right? Okay, got it?
Excellent.
Next one.